Yeah, so this is going to be about Correlator and Beamformer for the spotlight. Myself, Harshavardhan, I'm an engineer at GMRT. So I will give a little bit intro about GMRT. Most of you know, but GMRT is a Giant Microwave Radio Telescope. It's located around 80 kilometers north of Pune. It has 30 large dish antennas arranged in Y-shaped array with the 14 antennas in a central square kilometer area, and the rest of the antennas spread over 3 arms. And it operates at low frequencies, and the baselines are from 100 meters to 25 kilometers, giving good coverage in the UV plane. It's one of the most sensitive radio telescopes at low frequencies, and also it operates in 2 modes, interferometry for imaging and array for study of transients. Now, this is about the digital backend for the GMRT, upgraded GMRT or the GMRT. Why I'm giving this is because Spotlight runs in parallel with the current existing backend in commensal mode. So this GWB is a hybrid backend built using FPGAs and GPGPUs. FPGAs with ADCs actually sample the baseband signals and then digitize the data. And there is a Walsh demodulation also present in the FPGAs. And that data is sent to servers with GPUs for processing. So the maximum instantaneous bandwidth is 400, but it also supports lower bandwidths. It also supports 4 beams, which can be configured as IAPA or post-correlation beams at very good time resolution. We can actually have 1 or more spectral voltage beams in place of these 4 beams and do the coherent dispersion. Now, GMRT is very sensitive and it's a good instrument, which is good at imaging and localization. But Spotlight actually comes and fills the gap, making it a survey telescope covering the large field of view with so many beams. So basically, Spotlight actually is a commensal system which does fast transient surveys with the GMRT. So in the interest of time, I won't expand the Spotlight acronym. This is how the processing of Spotlight is. From the antennas, we get the baseband data, and in the Correlator Beamformer, we are processing this baseband data and forming 2,000 post-correlation beams and sending it to the pipeline, which actually uses an AI-based detection, burst detection and transient detection. So upon detection, what we are going to do is we are going to record the actual baseband data and also the visibility data that is formed at high time resolution, which is 1.3 milliseconds, and also the beam data into a 2 petabyte storage. All this is connected over a 100 gig InfiniBand. And post recording, we will be doing the real-time imaging and localization, and also processing the baseband data for very high time resolution. So this is the same block diagram which Jayanta has explained. So I will be explaining about the Correlator and Beamformer, and little bit about controlling and monitoring system because are interconnected. So the Spotlight, we have total 60 servers, which are Rudra servers, which yesterday Ashish and team has explained. With 90 A100 GPUs, giving good compute capability. And the data rate that we have coming from the antennas, the baseband data is 24 gigabits, and the beam data that we are forming is 6 gigabytes per second. So it forms 2,000 post-correlation beams. In the first stage, there are 20 servers, and out of them, 16 we are using for the correlation and beam formation. And in the second stage, there are again 20, and along with the other 4 in the first stage, we'll be doing the FRB detection, AI-based FRB detection. And in the third stage, we'll be doing the imaging and localization. So this is about how we get the signal from the GMRT antennas to the spotlight, because it has to run in commensal mode, catering to all the other observations happening at GMRT. So on the left side, you can see the GMRT signal flow. I won't go in deep into the signal flow, but I need you to concentrate on these yellow blocks and the bottom part, where in the analog backend, we process the RF signals and get the baseband data, and we send it to the digital backend, which is GWB. In parallel, we have Spotlight here and also the upcoming GMRT parallel backend. So how we are getting this copy of data? As I said, GWB has at its front end the FPGAs with ADCs connected. So the FPGAs that we are using are Casper-based Roach boards. These Roach boards have actually 4 10 gigabit Ethernet links, but for the GWB, we'll be requiring only 2 of them for its data rate. So the other 2, we can use it to send the extra copy. So we are making a copy of the baseband digitized data and sending it through the other 10 GB links, the copy. So, so this is how we are getting, after copying the data in the FPGA, and we are sending it to a conversion stage, because the Roach boards are having nearly obsolete CX4 connectors. The first stage is converting to SFP, and then we are sending it to VLAN to make an extra copy, to send 1 copy to the upcoming GMRT parallel backend and 1 copy to the Spotlight, which there is another extra conversion stage from SFP to Cat6, because Spotlight Rudra servers take Cat6 inputs. Now, actually these 2, all these processing stages are distributed over 2 shielded rooms. Actually, first is a Correlator room, and this is a Spotlight room. There is waveguide running with all the cables going from one room to another room. So these are some of the specifications. So I said we are forming the post-correlation beams. I will come to why we are forming the post-correlation beams. And then for the steering of beams, we are doing the baseline-based adjustment of phases for steering, and we are flagging the shorter baselines to remove the RFI effect. And as I said, we are recording the raw data when we have detection, and also the visibility data, which is at 1.3 millisecond time resolution. And the bandwidth, it covers the entire bandwidth, 400 megahertz. And the current release actually supports 800 beams, and we are doing optimizations to increase it to 2000 beams. The Correlator beamformer actually runs up to 800 beams. Then the time slicing, we are using the time slicing model, where for the Correlator, you need all antennas data in one node for the correlation operation. So we can't have all the data of all antennas in one node. So we are doing the time slicing and getting a small chunk of data in all the machines. And the overall processing load is 85 teraflops, and majority of it is taken by the beam steering part. So this is about post-correlation. Actually, in the post-correlation, how we are forming is we are first getting the visibility data after correlation, and then we are taking the cross products and adding them without any self. So because of this, we will be losing some sensitivity, but it gives more because it removes the RFI and other systematics in the chain. So this is about design, top level design of Spotlight. You have 16 nodes in the first stage and 24 nodes in the second stage. This is about what is happening in each node. As we are getting the data, doing the time slicing, and sending it to GPUs. And with the visibility data, which is formed at 1.3 milliseconds, we are integrating and getting 1 second resolution out. This is just for monitoring and also doing the phasing of all the antennas and removing, finding out bad antennas so that we can remove them. So these computational IO requirements, I will not go into detail, but just to say that all the computation and IO requirements are within the capability of the system. And memory requirements, we require huge memory requirements because we are buffering the data, beam data, baseband data, everything we are buffering for the FRB pipeline to detect it and then go back and record that the same visibility and baseband data. So that's why we need a huge amount of RAM, and that is also accounted and it is within the limit. Now coming to control and monitoring, we have the running control and monitoring system, which is Tango-based control and monitoring system for GMRT. What it does is it sends all the metadata to the GWB's main server. The GW main server, it is stored in a shared memory where Spotlight server actually gets that shared memory and can run in command support. And the Spotlight server also does other activities like doing the visibility recording at 1 second and doing the phasing and also sending it for monitoring. So there are two modes of this operation of Spotlight. So one is commensal running along with the GWB, and the other you can run it independently, directly the TGC sending the metadata information to the Spotlight. So this is how sample plots of monitoring. This is the cross phase spectrum before phasing, and this is after phasing. And we have the facility to monitor the band shapes, the self band shapes and the cross spectrums, and also the cross phase spectrums and also the visibility counts. So coming to ongoing developments, we are actually going to develop offline correlator to process the baseband data that we are recording when we have an event detection. That we will be having full polar visibility data at very high time resolution along with full polar beams. And also we are going to, I said, the current correlator and beamformer supports up to 800 beams in real time. So we will be optimizing it to run up to 2000 beams. So yeah. In summary, yeah, Spotlight is a real-time commensal search system for GMRT, forming 2000 post-correlation beams and ability to record raw data and visibility data in detection. Thank you. Any questions?
Questions for Harshavardhan?
Yeah, thanks, Harshavardhan. That was a really nice talk. So actually, I have two quick questions. You said that you are replicating data, right? Because you're parallelly streaming packets to multiple backends.
Yeah.
Have you seen any issues with like losing a bit of efficiency because of data replication, like when you replicate packets?
At the moment, no, we haven't seen any. It is quite efficient. It's very good.
Okay, so you're not losing anything.
We are not losing anything.
Okay, I'm glad to hear that. And also about the transient buffer when you're going to save the raw voltages. So are you also saving the full solution so you can do like, what are the plans for polarization calibration of those data, especially for FRBs? Because that will give you access to the to study the, allow you to study the polarization for these things. So I was wondering how you plan to do that.
Yeah, we are going to have a facility where you can adjust it in the offline correlator. But for the recording, while recording the baseband data, we will be recording all the visibility data also on the calibrator.
Okay. Yeah. Okay. That was my question. All right. Thanks.
Yeah. One last question from Prabhu.
Sorry, Ashwatan. Maybe a nice talk. Maybe I missed to understand. Is the full polar is now operational or?
No, it is going to come.
Okay.
Because the current correlator beamformer, it is in the total intensity mode. So offline correlator will be in full polar mode.
Thank you.
All right, let's thank Harshavardhan and